Don't forget to write your student numbers in the chat. Please, before we start, type your student numbers in the chat for me, so that then we have a record that there were students in this session for the attendance register. Okay, so today we're going to do hypothesis testing and chi-squared, like I said. The 2 hours that we have, we need to make sure that we cover both concepts. And the hypothesis testing is the longest session. So we'll see how it goes. So for the first 1.5 hours, we will do hypothesis testing. And since it's also broken down into 3 sections, so we do hypothesis testing for the mean when the population standard deviation is known or when it's unknown. And then we also going to do the hypothesis testing for the proportion. And then we'll end the session by looking at the confidence the chi-square testing. And with the chi-square testing, we only going to look at chi-square for independence. So we're going to learn the basic principle of hypothesis testing. In the past week, we learned about confidence intervals and the sampling distribution. The very same concept we used in those 2 sessions, we are going to apply them in this session as well. So we're going to still use the T-table to go find the critical values. Remember, we used the critical values when we were calculating the confidence interval. We're going to use the Z-table to find the critical values as well. And we're going to use the standard errors to calculate the test statistic, which is just the sampling distribution formula. And you remember we did the sampling distribution for the proportion and for the mean. We're going to use those 2 formulas and expand it with when the population standard deviation is unknown, when we've not given the population standard deviation, but we're given the sample standard deviation. So the same concept with learned, we're going to continue with that. So what is hypothesis testing? A hypothesis testing is when a researcher wants to prove that something that they are saying is right or is wrong. For example, if I want to prove that people like the ANC, if I haven't run a research on that and prove that people did say they like ANC, I cannot make that assertion. I cannot make that claim that people like the ANC as a political party or a ruling party. You cannot do that. So that is why you need to collect the data and do a hypothesis testing so that you can test that assertion. And that's what hypothesis testing is about. The researcher will want to claim about a certain phenomenon. And we usually use the population parameter to test that, because the data have to go back and infer it back from the sample. You have to take back the results and infer them back to your population. So we can use the population mean or we can use the population proportion to make that claim. There are several concepts that we need to know. When we make a claim, we always say there is 2 sides to a story. So with this hypothesis testing is that we're going to test the hypothesis, which is our null hypothesis, and then there is an opposite of whatever the claim is, which we call the alternative hypothesis. So a null hypothesis This is the claim that the researcher wants to prove. And since we're using the population parameter in your null hypothesis, you're always going to state that using the population parameter. Like with this statement, it says the mean diameter of the manufacturing bolt is 30 millimeter. So the null hypothesis, how we state it, we put H naught, which is a subscript 0, dot, the mean mu for population parameter is equals to state. And that's how you state your null hypothesis. But there are other things you need to know about how you put your claims on your null hypothesis. In your null hypothesis, we always use the population parameter. That's one we know. We always use the population parameter, not the sample statistics like the mean weight, the X bar or the S. We use the mu, the Greek letters. We use the mu, sigma, we use the proportion, which is the pi in this instance. Also, when you state the null hypothesis, you can either reject the null hypothesis or do not reject the null hypothesis, because we're looking at this as the assumption that you are making. You can prove it wrong or you can prove it right. This is similar to the notion of you are innocent until you proven guilty. And always, when you state the null hypothesis, there should always be an equal sign. So either it is equal, or it is greater than or equal, or it is less than or equal. And both of these, they tell a story. But in terms of a null hypothesis and alternative, so in terms of the null hypothesis, there is always going to be an equal sign. So therefore, it means most of the time, your null hypothesis will always carry an equal sign. What I mean is, you don't have to worry about the greater than or equal or the less than or equal. It's always going to have the equal sign. Okay. The alternative, which is the opposite of the null hypothesis, we can state the opposite. So if our null hypothesis said it is equal, therefore the opposite will say it is not equal. Because this hypothesis will challenge the assumption that you made earlier, or the claim that you made earlier. And your alternative hypothesis does not contain a null, an equal sign. So it means in your alternative hypothesis, there should not be an equal sign. So it means you're going to say it is not equal, it is greater than, or it is less than. With alternative hypothesis, we use it to make the case for us rejecting the null hypothesis. So we just use information that is on the alternative to make decision for the null hypothesis. What do I mean? It means the sign that we put in our alternative hypothesis tells us a lot. It will tell us whether are we doing a two-tailed test or a one-tailed test based on the information that we have. So this tells us we're doing a two-tailed test. This greater than or less than, they tell us we're doing a one-tailed test. So it means when we make a decision, we're going to be looking at two areas of rejection, and with the one tail, it means we're looking at one region of rejection. And I will take you through all those steps later on. So, and most of the time, we usually put here the claim that the researcher wants to prove, even though we know that the researcher wants to prove needs to go into the alternative, but sometimes because the researcher might say it is less than or it is greater than. And with that claim, we can only put it on the alternative hypothesis. Just give me a sec. Okay, so when we make a decision based on the null hypothesis and the alternative, there are some certain errors that can also happen when we make those decisions. And the first error that can happen is what we call type 1 error. With type 1 error, it is when we reject the true null hypothesis, and also it is also considered as a very serious type error. And it is also denoted by alpha, which is our level of significance. And this is always set at the beginning by the researcher. The other type of error that can occur, it is what we call a type 2 error. And this is when we fail to reject a false null hypothesis. What do I mean by these two errors? So let's say the researcher wants to prove that the mean. So in our null hypothesis, we say the mean is greater than 30. And in our alternative, is the mean is less than 30. No, now let's say we want to prove, the researcher wants to prove that the mean is less than 30. Remember that? The researcher wants to prove that the mean is less than 30. But we know that the researcher wants to prove always goes to the null hypothesis. So, since we know that the null, the mean less than 30 needed to go to the null hypothesis, that's what the researcher wants to prove, but we put it in the alternative, not H0, H1. So when it comes to type 2 error, it is in the null hypothesis, we have put the false hypothesis because this is not what the researcher wants to prove. So if the answer we get at the end when we make the decision and conclude, and we come here and we do not reject the null hypothesis, if we do not reject that null hypothesis, therefore we are committing a type 2 error. If we are not rejecting that null hypothesis, we are creating a type 2 error. If we're not rejecting that, that is what we're failing to reject the false null hypothesis. But what if the researcher wants to prove that at most, therefore, if the researcher wanted to prove that at most, which is less than, we are able to put it less than or equal because that's what the researcher wants to prove. So our alternative will be greater than. So when we have to make a decision at the end. When we reject this null hypothesis, if we reject this, we are committing a type 1 error because we are rejecting a true null hypothesis. And those are the two errors. So how do we then do the hypothesis so that we can see how we create all these errors as well? But in your course, you just need to know the theory and know how to calculate or create the hypothesis. There are 6 steps of hypothesis testing. The first step of the hypothesis testing is always to state the null hypothesis and the alternative hypothesis. Step number 2 is to state what else are you given based on the information that you will be given in the paragraph. In terms of the level of significance, which is your alpha. Remember, if they didn't give you alpha, they will give you a confidence level, which is at 95% confidence level, which you can calculate your alpha, which will be 0.05. You also can state your N and do other calculations if you want, if they haven't given them to you. Step number 3 is to determine what kind of a test are you doing based on the information that you are given. Like, for example, you will determine whether sigma is given or is not given, like your population standard deviation is known or not. Because when your population standard deviation is known, we know that we're using the Z. So it means we'll use the Z test statistic. If it's unknown, we're going to use the T test statistic. And that's what you state there on your step number 3, just stating the kind of a test that you're going to do, T test or Z statistic test. Step number 4, you're going to find the critical value. Remember, the critical values are your Z values. We did the critical values when we were doing the chi-square, when we were doing the confidence interval. So those critical values, you're going to state them. For T, you're going to find the critical values by using the degrees of freedom and alpha. And also finding the critical values, it also depends on the statement you have on your alternative hypothesis, whether you're doing a one-tail test or you're doing a two-tail test. Because if you're doing a one-tail test, you're only going to find your critical value by using alpha. Sorry, if you're doing a two-tail test, you're going to find your critical values using your alpha divided by 2. If you're doing a one-tail test, you're going to find it by using alpha only. And if it's T, you will say alpha in the degrees of freedom. We'll look at the example in more detail. Step number 5, you're going to calculate the test statistic that you identified. Whether it's a T, whether it's a Z, you calculate that test statistic. Step number 6, you make a decision and conclude whether you're going to reject or not reject. Also, this is based on whether you're doing a one-tail test or a two-tail test. So if you're doing a one-tail test, you will only have one region of rejection. We'll look at that just now. And when we're doing a two-tail test, you will have 2 regions of rejection. So what do I mean by those? So if I'm doing a two-tail test, it means in my alternative, it will say not equal. Therefore, it means I have 2 regions of rejection, which I will find are defined by the critical value. So if my critical value is 1.96, therefore the site will have 1.96 in the negative and positive 1.96 because it's a two-tail test. And if I calculate my Z value and it falls in the region of rejection, I'm going to reject anything that falls in this area, the red area. And I am going to reject anything that falls in this blue area as well. So I'm going to reject anything that falls in there and anything that falls on the other side. But if it falls in the white area, I do not reject. This is the do not reject area. And this is only for two-tail test. For a one-tail test, where the mean is less than, so remember the null hypothesis and the alternative, you can put the greater than or equal, or it can just say equal. As long as at the bottom where the researcher sign is placed, where it says it's less than, it means we only have one region of rejection, and it will be in this negative side of the rejection area. Anything that falls in the white area, we do not reject. Similar with the upper tail area, which is a one-tail area as well. If it is greater than, we put it on the positive side, and anything that falls on this side of the area, we're going to reject because this is the rejection area. Anything in the white side of the area, we do not reject. Let's look at an example. We're going to look at how we do a hypothesis testing when the population standard deviation is known. And this is hypothesis testing for the mean. So with hypothesis testing for the mean, for now, we're going to concentrate on when the population standard deviation is known, then we're going to use the Test Statistic, which is the sampling distribution formula. You remember, we use this as our statistic. And this will be the Z-test that we use to make a decision, with including when we find using the critical value, or later on when we do the p-value. Then later on, we're going to look at when the population standard deviation is unknown, where we use the t-test statistic. So remember the 5-step: state your null hypothesis and alternative given, and the kind of a test we do. I'm just going to say it's the Z-test statistic. Determine the critical value. We're going to be using the Z. So we're going to go to the cumulative standardized normal distribution table to go find our Z values, Z critical values. And based on the sign in the null hypothesis and especially in the alternative hypothesis, it will tell us whether we're doing a one-tailed test or a two-tailed test. Then we calculate our test statistic, and then we make a decision and conclude. And this also based on whether we're doing a one-tailed test or a two-tailed test, where the region of rejections are, we make a decision and we conclude based on the test statistic and the critical value. Example of how we do this: test the claim that the true mean diameter of a manufactured bolt is 30 millimeter. Assume that the population standard deviation is 0.8. The level of significance alpha is 0.05, and your sample size n is 100. First step: state your null hypothesis and the alternative hypothesis. If we read the question, test the claim that the true mean diameter of the manufactured bolt is 30 millimeter. There and there, it tells us this is an equal sign. Stating the null hypothesis, the mean is equals to 30. The alternative will say it is not equal, because it will be the opposite of that. And this is a two-tailed test, and it helps because then now I will know how I'll find my critical value. I'll use alpha divided by 2. I know that then when I do the conclusion and I make a decision, I will have two regions of rejection. Specify what we are given. Everything that is at the top is what we are given. That is written in red. So we can state all of them. Or in terms of alpha and n, we're given 0.05 and n is 100. Step number 3, determine what kind of an test we're going to be doing. We're doing a Z-test. That's all what we need to know, because population standard deviation is known. So we're doing a Z-test. Step number 4, we need to go find the critical value. Finding the critical value, we are given alpha of 0.05. So our alpha of 0.05, it means our Z of alpha divided by 2 will be Z of 0.05 divided by 2. I'm just repeating this, but we also did this in the when we were doing the confidence interval. So it's the same thing, 0.00250. Then you go to the table, the Z table, and you look on this. Inside the table, there should be 0.0250 value. When we go out of the table, you will see there it will have minus on this side. It will be minus 1.9, and then at the top it will have 0.06, and that is our critical value. That will be our critical value, which is 1.96. That's how you will find your critical value. Step number 5, we calculate the test statistic. Remember, we're using our Z test. So our N is at 100, sorry, our mean X bar is 29.84 and our population standard deviation was 0.8. Statistic, we substitute the value 29.84 minus the mean. Remember, in our null hypothesis, we stated that the mean is 30. So 29.84 minus 30 divided by the standard deviation of 0.8 divided by the square root of the sample size, which is 100. So solving what is at the top, 29 minus 30, we get minus 0.16. 0.8 divided by the square root of 100, we get 0.08. And this gives us minus 2, which is our Z test statistic. Now we're ready to go make a decision based on this value and the critical value we found, which was 1.96. The best way to make a decision is always to draw the graph, because it makes things visual. Instead of you remembering all the rules, you can make yourself a picture like that and make a decision like the one we used earlier. So making the decision is our last step. Draw our picture. We put our critical value, define our region of rejection. Remember, we found that our critical value was 1.96. Put there in the negative side, our 1.96, and on the positive side, our 1.96. And clearly define our region of rejections for both areas. Our Z test was -2. Where does -2 falls? If it falls in this side, we do not reject. If it falls on the other side, we go into reject the null hypothesis. Alternatively, if you don't want to use a graph like this, you can always use the decision. This is the decision, which states that we reject the null hypothesis if the Z test is less than 1.96 or if the Z test is greater than 1.96. If you remember all that, you don't have to draw the graph. If you remember all this, that for a two-tailed test, you have two regions of rejection. When it's less than minus 1.96 or when it's minus less than the critical value, we reject. Then we do not hypothesis if it does not fall within those areas. So if it's less than if Z stat is less than the critical value or the Z stat is greater than the critical value, we reject the null hypothesis. Otherwise, if it falls in between the two values, we do not reject the null hypothesis. So where does our Z of -2 falls? It falls on the rejection area. Therefore, we can make a decision. We can conclude that hence our Z test of -2 is less than 1.96, and we know that it falls in the rejection area. Therefore, we're going to reject the null hypothesis and conclude that there is sufficient evidence that the true mean diameter of the manufactured bolt is not equal to 30. And that's how you make a decision. Looking at this example, I am going to do it for you because I have run out of time for this. So we're given a statement, if n, a sample size of n, or if in a sample size of n equals 20, select from a population the sample mean of 58 and the population standard deviation of 12. Wait, let me reread this. I'm not reading it right. If in a sample of n equals to 20 is selected from a population with the sample mean of 58 and the population standard deviation of 12. Suppose that the e-tutor wants to test the following hypothesis. The mean, or with the null hypothesis stating that the mean is equals to 55 and the alternative mean is not equals to 55. Based on this information, at 5% level of significance, based on this information, we can clearly see that this will be a two-tailed test. Therefore, it means we're going to have two regions of rejection. We're going to use critical value, we're going to use alpha divided by 2. So that will answer number 1. But before I answer number 1, I answer all the questions, we can use our 6 steps of null of hypothesis testing. So the first step, they have stated our null hypothesis and our alternative done. State what you are given, that is step number 2. Our alpha is 0.05. Our n is 20. Step number 3, state what kind of a test are we doing. We are told population standard deviation is 12. Therefore, we are doing a Z test statistic. So Z test, that's what we are doing. Step number 3, we stated what the test we are doing. Step number 4, find the critical value. Finding the critical value, since we're doing a two-tailed test, we're going to use Z alpha divided by 2, which is Z of 0.025 when we divide 0.05 by 2. And this we know that it's 1.96. We know that. We did an exercise earlier where we used alpha of 0.05. That is step number 4. Step number 5, we calculate the test statistic. Calculating the test statistic, Z is equals to the mean minus the population mean divided by the population standard deviation divided by the square root of n. Now, everything that is underneath this, the equation here, we call this the standard error. So let's rewrite this here because I want to substitute the values. So we know that Z is equals to the mean minus the population mean divided by the population standard deviation divided by the square root of n. So we know that our error is standard deviation divided by the square root of n, which we know our population standard deviation is 12. So that will be 12 divided by the square root of 20. And that should give us the answer of 12 divided by the square root of 20 gives us 2.683 and some number. How many digits? 33. 2.833. That is the standard error. So coming here, we can substitute the values. Our mean, sample mean is 58 minus our population mean. We find it from the question. It's 55 divided by 12 divided by the square root of 20. And the whole answer, if I calculate all of it, is 58 minus 55 divide by 12 square root divide by the square root of 20 equals. And the answer is 1,1180. 1,1180. That is step number 5. Step number 6 is to make a decision and conclude. Making a decision, I'm going to draw a graph that looks like this. And because it's the two-tailed, I'm going to put here minus 1.96 and I'm going to put here positive 1.96. Looking at our z-test, I can make a decision. Anything that falls here, we reject. Anything that falls in here, we reject. And here we do not reject. So now, if I go back to our question and see if I can answer all the questions that they asked. So number 1, we're looking for the incorrect answer. Number 1, that is correct because it's a two-tailed question. Standard error, we calculated the standard error, which is 2,6833, which is correct. The test statistic was step number 5. We calculated it. It's 1,1180, which is correct. Are we rejecting the null hypothesis? Let's make that decision. Our critical value is 1,96. Our test statistic was 1,1180. It will fall somewhere here. Oh, sorry, not there, because if this is 0, it will fall somewhere here. Therefore, it falls in there. Do not reject the null hypothesis. Here it says H0 is rejected. Therefore, that is not correct. Our critical value is 1,96, and we found that. As you can see, all 6 steps of a null hypothesis can be asked as an option in one of the questions that they are asking there. So you need to know all 6 steps of null hypothesis testing in order for you to answer the questions in the exam relating to hypothesis testing. Okay. Alternatively, if we're not using the critical value to make a decision, we can use the p-value. And when we use the p-value, the decision is if the p-value, which is our probability, if the p-value is less than the alpha value, we're going to reject the null hypothesis. Now, there are several things you need to always know about the p-value. What is the p-value? The p-value is the probability. We only do this for the z-test. For the t-test, they will never ask you to use the p-value to make a decision. Only for the z-test, because it's easy to find the p-value for the z-test. There are several things you need to also remember when you're using the p-value. We have a one-tailed test and a two-tailed test. So for a two-tailed test, if it's a two-tailed test and the answer you get is positive, what do I mean the answer you get is positive? If your Z value that you calculate your test statistic, so for example, like here, our test statistic is positive, it's 1,9, it's 1,11. It's positive. For a two-tailed test, if your Z value is positive, you're going to find the probability by going to the table. The value you find in the table, you're going to, this is your p-value from the table. This will be your p-value. The value you find using your Z values, the value you find from your Z values you're going to say 1 minus the table value you find, but that's not the end. Once you have that value, you're going to multiply that value by 2. That is for a two-tail when it's positive. When your Z value is negative, then it will be the probability you find on the table. This is the same thing as we did when we were looking at chapter 6 and chapter 7. When we were looking at normal distribution or sampling distribution, the value you see on the table is the value you will use. This is for the two-tail tape, for the two-tail. For a one-tail, the value you see on the table is the value you see on the, is the answer you get. So for one tail, p-value, it will be the table value, because with the p-value, we use the z values to go find the p-value. So the value you see on the table will be the answer for your question. Only for a two-tail, you need to multiply it by 2. You will also multiply this by 2. Even if it's for the negative, you're always going to multiply by 2. So how do we then do this decision? We make a decision. We follow the 6 steps. It's similar to that. I'm not going to repeat all the steps. Remember, it's all the 6 steps. But in this instance, you're only going to do 5 steps because we're not going to calculate the critical value. It's not important. And then I'm not also going to repeat this because we covered this. So you state your null hypothesis and your alternative hypothesis is the same thing that we just covered now in the exercise that we did. And you calculated your Z test. We found that our Z test was 2. Now we're ready to use this Z test to go make a decision. To do that, we take the Z test, we go to the table. We go to the table because it's negative. Remember, if it's negative, we're going to multiply the value we see on the table by 2 to find the answer. So if you go to the table, the Z table, remember, you go look for minus 2.0 and 0.00 at the top. When you do that, you will see that the answer you will get will be 0.0 to 8. That will be your Z value. And then we're going to add both sides or multiply 0.0228 multiply by 2, and the answer we'll get will be 0.056. And we can make a decision. The decision says if p-value is less than alpha, we reject the null hypothesis, and p-value is less than alpha, we're going to reject the null hypothesis. The same question, same information. Either we're using the critical value or we're using a p-value, we find the same conclusion. Let's look at one example. Suppose the p-value of a one-tail test, since now they say a one-tail test, so now you need to be very careful here. It's not a two-tail, it's one tail. So it means we need to go to the table. You go to the Z table and you go look for, this is a test statistic. So since on a Z table, with only two values. Oh, sorry. This is, the question says, suppose the p-value for a one tail is 0.092. So it says, based on this information, based on the same population, the sample and the null hypothesis sample and the null hypothesis, the p-value of the corresponding test statistic or two-tailed test will be. Now, remember the first time I said, that's the other thing I need to amend on that the decision we made. If I go back here, remember I said if it's positive, the value we find. I forgot to mention this. If the value you're going to find in the is in the positive side of the table. Remember, the positive side of the table means the greater side of the things. So if the value you find is of the Z value, it's positive. Remember we said we're going to subtract the value we find on the table from 1. So if I need to open the Z table just now, give me a sec. Okay, let me stop sharing this. Remember that one tail, it said it's 0, 0, 0,0092. So I just want to go to the Z table first before I share my screen. Okay, so for a one tail, our Z was 0,0092. So we know that we need to say Z is equal to 0,01 because we need to round it off to 2 decimal. So since it's 0,01, we need to go to 0,0, so go to 0,0, the first 2 digits, 0,0, and we go to the top. We look for 0,01, and that will be our answer, which is 0,5040. So since this was a one-tailed test, that would have been the probability, the p-value, but 0,540. Since now, if we go back to our question, go back to our question. So we know that with this, our Z would have been 0,01. Therefore, our p-value for this would have been 0,5040. But we're looking for the answer for the two-tailed test. So since we're doing for the two-tail, I hope you see, okay. Since we're looking for the two-tail, remember, it's 2 times 1 minus the table value for a two-tail. So now it's going to be 2 times 1 minus 0,5040, and this will give us 1 minus 0.5040, which is 2 times 1 minus 2 times 0.496. And if I multiply this by 2, and the answer you will get will be 0, 9920, which is not on here. How possible? Oh gosh. Oh, sorry, my bad. Wait, shoo, and I cannot go back to the table. I am doing it all wrong. Sorry, my bad. I've interpreted it all wrong, all wrong, all wrong, all wrong, all wrong. Sorry. They have calculated, they found the p-value. So they found the value on the table. Sorry, my bad. They found the value on the table and they found that it's 0.0292. My bad. 92. Sorry. So this was their p-value. So remember with the Z, with the two tail, so for a two tail, it will be 2 times the value they found as a p-value on the one tail table. Therefore, it means we're going to just multiply 0.92 by 2. Sorry, my bad. I am in my mind, I'm using the Z instead of the p-value. And this gives us 0.0092 times 2, sorry, my bad, which is 0.01884. Apologies for that. And that's how you will find the answer.
I have a question.
Yes.
So don't you say times 2 when the value is negative?
No, for all of them, for all. So you do times 2 for all, even if, remember now, why I confused you. Let's go back there. For both of them, you will always have to say, so when it's positive, you will say 2 times 1 minus the value from the table. But when we are using the Z positive, if it's Z negative, you're still going to say 2 times the table value. So now we know the table value was 0.92, which is our p-value. Remember, the table value is our p-value. And we cannot call it the p-value as yet because we need to still multiply that by 2 to get the p-value. So this is multiplying by 2 to get the p-value. So there is our p-value for one tail. So we don't know whether it came from the negative or the positive. It doesn't matter at this point. We know that from using that one tail, we can calculate our two tails value. And since we're doing a two tail, therefore it means there are 2 regions of rejection. Therefore, we have to multiply that to get the true 2 p-value. For a two tail test, we need to multiply by 2. Okay. And that is hypothesis testing for the mean when we make decision using the critical value and when we're using the p-value. Now we move into doing a hypothesis testing when the population standard deviation is unknown. I'm going to rush through this one because the same steps applies. So it's just to show you how to do another kind of a test. We're not going to concentrate more on the technique. So this is when the population standard deviation is unknown, we know that we're going to be using a t-test, and therefore the test statistic is the sampling distribution formula for t-statistic. So, for example, remember, we still need to remember all the 6 steps of hypothesis testing. So if this is the average cost of a hotel room in New York, $468 per night, and we do a random sample of these hotels was taken with the mean of 172 and the standard deviation of 15.40. So they give S, it means they give us the sample standard deviation. We need to test at alpha 0.05. So the step number 1, we state the null hypothesis and the alternative. The mean is equals to 168. The mean is not equals to 168. So remember all those steps of hypothesis testing. So we go and we start. The mean, we stated that the mean is equals to 168. The mean is not equals to 168. Therefore, we're doing a two-tailed test. State what you are given. Step number 2. We state what we are given. Our alpha is 0.05, n is 25, and in this instance, we can also calculate the degrees of freedom because we're going to use it when we find the critical value. What kind of a test we're doing? Step number 3, we're doing a t-test statistic. Finding the critical value, remember we go to the table using our degrees of freedom, which is our degrees of freedom, and alpha. Since it's a two-tailed, this will be alpha divided by 2, which is 0.05 divided by 2, which gives us 0.025. So our alpha divided by 2 and the degrees of freedom, when we go find the critical value on the T table, we find that it is 2.0639. We create our region of rejection and we go and calculate our test statistic based on the values. We'll use those region of rejection to make a conclusion, because once we have calculated our test statistic, from substituting all the values, we find that our test statistic is 1.46. Where does 1.46 fall? It falls in the do not reject area, and we can conclude that we do not reject the null hypothesis because there is insufficient evidence that the true mean cost of is different from 168. And that's how you will make a decision. Based on the same information, or not the same information, we can look at a one-tailed test, how we make decisions based on a one-tailed test. So the mean is less than 52, less than or equals to 52 Rand, and the mean is greater than 52. So since it is greater than, it means we're doing a one-tailed test. State the null hypothesis and alternative hypothesis based on the information given. State what you are given, including also the degrees of freedom. What kind of a test is this? It's a t-test. Find the critical value. Step number 4. Step number 5, we go, this is how you make a decision. Step number 5, we calculate our test statistic and we find that our test statistic, step number 5, test statistic is 0.55. Make a decision. Remember, our critical value was 1.318, and we calculated the test statistic was 0.55. It lands there, and therefore we do not reject the null hypothesis, since our test statistic of 0.55 is less than or equals to 1.31. And that's how you will make a decision. I was just demonstrating how the steps are the same. It's just how you calculate, the formulas will be different. Okay. I'm not going to ask you to do this exercise. We're just going to go straight into doing a hypothesis for the proportion. Let me see, 30 minutes behind. Okay, so we right on time if we don't do that exercise. So let's look at the proportion. So doing the proportion also, the 6 steps applies for the hypothesis testing. And since the proportions work almost the same with the, we use the Z test, we can also use the p-value to make a decision, or we can use a t-test, a critical value. With the proportions, the test statistic that we're using, remember, is the proportion formula from the sampling distribution. If your sample proportion is not given, if your P is not given, we can calculate it by using the observations satisfying that sample divided by the sample size. And this, the sample proportion minus the population proportion divided by the standard error, that's the Z test statistic that we're going to be using for the proportions. So like I said, if it's not given, if our sample proportion is not given, we're going to use X divided by N. Looking at an example, a marketing company claims that it receives 8% responses for its mailing. To test this claim, a random sample of 500 were surveyed with 25 responses. So they give us our X and our N alpha and our population proportion of 8%. The 6 steps of hypothesis testing, you remember them. Now let's answer that question. We state the null hypothesis and the alternative. The population proportion is 8%, so it's 0.08. The alternative will state that it is not equal. Therefore, we're doing a two-tailed test. That was step number 1. Step number 2, state what we are given. Since also with this, we were not given the P, we can calculate our P, which was X divided by N, and our X was 25 divided by 500, and that gives us 0.05. Step number 3, state what the test statistic we're doing as a test. That will be step number 3. Step number 4, we go find the critical value. We are using alpha of 0.05. By now, you should know that when it is Z alpha divided by 2, for a 0.05, your critical value will be 1.96. We should know that by now. If not, you can go find it on the table. Step number 5. So with the critical value, we are able to create our region of rejection. Step number 5, we calculate the test statistic, substituting all the values and making the calculation. We find that the answer is minus 2.47. We can then now make a decision. Our p-value falls in the rejection area. We can conclude, since our decision is if it falls, if it's less than our alpha, our critical value of minus 1.96, we're going to reject. Therefore, we're going to conclude by saying there is sufficient evidence to reject the company claim of 8%. And that is how we do hypothesis testing. In terms of the p-value for the same exercise, we go use the answer we got of minus 2.47. Since it's negative, we're going to find the value on the table and multiply that value by 2. Go to the table, we go find the value on the table, which is 0.0068. We multiply that value by 2, and that gives us 0.0136. And we can also reject the null hypothesis, since p-value is less than alpha of 0.05. I will pause right there if you have a question. Now is the time to ask. Then we go into an exercise for about 5-10 minutes, and then we move into chi-square.
Hi, Lizzie.
Yes.
I have a problem with the hypothesis testing. Like, for example, when it's not specified whether which test you're going to be conducting, like on a question, they don't specify whether you're doing a T or P or Z. How do you
No,
find out which one are you going to be calculating?
they will always specify. You just need to read the statement carefully. For example, like this, how will I know whether is this which hypothesis testing is this? By looking at the things that they give you in the statement. If you look at the statement, they didn't give you anything relating to the mean or standard deviation. So already you can see that they talk about hypothesis. So then it means this is the hypothesis testing for the proportion. On the other hand, on the other one where it is the mean, for the mean, I'll have to go back to the question that we didn't do just to demonstrate the point that you are raising. So, for example, like with this question, if you look at it, they didn't say anything here about the population standard deviation or the sample standard deviation. They're giving you the data, and this is the sample data. So it means they didn't give you the population standard deviation. So your population standard deviation in this instance will be unknown. So you will be using a Z test. So these are the things that you need to know. So some on the previous exercise, they did mention that the population standard deviation is equals to this. Then it makes it easy for you to know that this, then it means if the population standard deviation is mentioned, it means we're using a Z test. If the population standard deviation is unknown, but they give you the sample, you're using a T test. And that's the only way you will know which one you need to be using.
Thank you.
Yes. Okay, so let's go to the exercise, which is this exercise. You're not going to also do this. I will do it for you because I'm looking at the time. I need to spare a little bit more time from this session to do the chi-square as well. So an airline claims that only 6% of the lost luggage is never found. If a random sample of 17 of 200 pieces of lost luggage are not found, test this hypothesis that the population proportion of 0.06 against the alternative that states that the population proportion is not greater or is greater than 0.06. So they already stated our null hypothesis and alternative. Based on this information, we're doing a one-tailed test. This is a one-tailed test. And I'm not going to look at what the answers are telling me. I'm going to do the 6 steps and then I'll come to the question and answer this. So our first step, answered. Second step, state what we are given. Our alpha. I'm going to assume that our alpha is given to us, which is given in the statement here, since we're not having all those. So our alpha is 0.10. Our n is 200. Our p is 17 divided by 200, which is equals to 17 divided by 200, which is 0.085. Number 3, we're doing a Z test statistic. Number 4, we need to calculate our Z. I'm going to move it a little closer to the questions there. Z. P minus our population proportion divided by the square root of our population proportion, 1 minus our population proportion divided by n. Substituting the values, our sample proportion 0.085 minus our population proportion It's 0.06, which is in the hypothesis testing statement. Divide by our standard error, which is 0.06 times 1 minus 0.06 divide by 200. Go to my calculator. First I will calculate the standard error, which is the value underneath this. We'll calculate the value underneath the square root, or actually I'll calculate the square root, the whole of it. Okay, the square root of 0.06 times 1 minus 0.06 divide by 200 gives me, it's a very long number, so I'm not gonna repeat all of the values, but when you're doing the exercise, you must write all of them. So I'm just gonna write few of them. 0.0, I'll leave it at 4 decimal. So 0.0167. So it will be 1679. I'll leave it at that. 0.01679. I'll leave it at that. And at the top, it is 0.085 minus 0.06 equals 0.025. So if I calculate all of it, 0.025 divide by 0.0179 and the whole other number. Quickly gonna calculate that. I will tell you what it is now. There. It is equals to 1,449. 1,49. Maybe I should leave it at 3 decimals. Otherwise, it's fine like that. Okay, now we need to, oh, I forgot. So this is step number 5, actually. I skipped step number 4. Step number 4, which was find the critical value. I don't have to worry about finding the critical value because I'm quickly flipping over here. It says we need to find the p-value. So we can go find the critical value by using our alpha of 0.10, but I'm just gonna ignore that and use our test statistic that we calculated just now. Using our test statistic, to go find the p-value. So our test statistic is positive. It's 1.49. So therefore it means our p-value, our p-value will be we're doing a one tail. Sorry, I must not forget that. This is a p-value. Since this is positive, we're going to, and since the value is greater than, we're going to say 1 minus the value we find on the table. That's the other thing we need to also remember. Based on the information we have here of greater than, remember how we were using the probability of z greater than a value. We say it is 1 minus the value you find on the table. The same concept happens here as well. So go into the Z table and I look for 2, is it 2 or 1? 1,49. Table disappeared on me. 1,4, and then 9 is the last one, the last column. So it makes it easy, I hope, because my hand is not going straight. And the answer here is 0,93119. So then it means we say 1 minus 0,9319319. And this is equals to 1 minus 0.9319 equal it feels like somewhere, somehow, I've done one calculation wrong, but we can just double check that. 0,0681. I can just double check because now I'm doing things in a hurry. So let's double check the one underneath the standard error quickly. Our standard error was 1 minus 0.06 equals times 0.06 equals divide by 200 equal, and take the square root of the answer. I have 0,0167 792,855, which is the right one. Unless the question here was looking for the correct, oh, we're looking for the correct answer. Oh, sorry, my bad. Sorry. I confused myself by going back to the question. Okay, so we have our p-value, and then the last, we can now start answering the question. So the first one says our p is 0,35. We're looking for the correct answer. I need to change my color to red. So we're looking for the correct one. So that is standard error, which is the value underneath. It's that value. It's not correct. The test statistic, we found it 1,49. This is 1,45. That's not correct. Our p-value is 0,14. The p-value should be 0,681. That's not correct. And the null hypothesis is rejected. And if I look at this, our p-value, our alpha is more than our, it will be more than, because our original, for the rejection, the decision is if the p-value is less than alpha, we reject. And this is greater than alpha, so we do not reject. And the statement here says we rejected, so that is not correct. The only correct answer was number 1. And that's how you do the hypothesis testing. So now, with the last 30 minutes that is left, we are going to look at how we do chi-square testing. Okay, so with the chi-square testing in your module, you only, I hope everybody who's here is doing 1510 or 1610. Let's stop right there. Are you all doing 1510, 1610?
I'm doing 1501.
You doing 1501.
Mm.
And can you please write your student numbers in the chat, please?
The chat, I don't know. I've been trying, but
What is that your student number that is on there?
yes, on my email it says 64350-924.
Okay, and then you'll have to write your student number on there. So if you're doing 1501, I just need to say thank you for being part of today's session. Your session ends right here. I'm going to continue with those who are doing 1510 and 1610 for this last bit, for this 30 minutes. Thank you, guys.
Thank you.
Yeah. So it doesn't matter if all of you leave, I will just continue with the session because I just complete today's session as well. So I might not hear you when you leave. You don't have to say anything. You can just leave the session because I'm just gonna record the part that is coming. Okay, so with chi-square for independence, we only do this one section. You don't do the goodness of fit test and so forth. So with this, we use what we call a contingency table, which is just a cross tabulation. You know that we did this when we were doing the probabilities. Remember, in the exam, if they don't give you the table with totals, you quickly calculate the totals. You just quickly calculate all these totals because we're going to use the totals when we do the calculations. And for chi-square test of independence, what we do, you always state in your null hypothesis that the variables are independent because we're testing for the relationship between two categorical variables. And in your alternative hypothesis, you're always going to state that the two categorical variables are dependent. The test statistic for chi-square test, we use the sum of your observed value minus your expected frequency squared divided by your expected frequency. I will show you how to calculate the expected frequency just now. Calculating the expected frequency, since I told you that the totals are very important, we use the row total multiply by the column total divided by the sample size. So you need to calculate the totals because you're going to use those totals to calculate your expected frequencies. Making a decision, we say if the test statistic is greater than our critical value, we reject the null hypothesis. And our critical value, we find it by using the degrees of freedom, which is the number of rows minus 1 times the number of columns minus 1. So let's look at an example on how we apply all this. If I have the planned meal by 200 students and it's shown here of these 200 students, and I need to test this hypothesis that the class standing, and the meals per week are related. The first thing I do is to state the null hypothesis and the alternative. The null hypothesis will state that the meal plan and the class standing are independent. The alternative will say they are dependent. Step number 2 will be to calculate or state what we are given. In this instance, we will be calculating the expected frequencies. Calculating the expected frequencies, which is our FE. Remember, it is our raw total multiplied by the column total divided by N. Remember that. So if I need to calculate the raw total for junior and 20 weeks, I look at the raw total, so which is for this, junior, which is for 10. So I go raw total, which is 30, multiply by column total, which is 70, and divide by 200, they will give me 10.5. I'm sure I'm using the wrong table here. I should be pointing on the observed table. If I need to calculate for 26, is your raw total for Sophia is 60, so it will be 60 multiplied by the column total, which is 88, divide by 200, which then will be equals to 26.4. Until you complete the whole table, you have all your frequencies table, your expected frequencies. Now we can use the expected frequencies to go calculate the test statistic. Calculating the test statistic, remember, is your observed minus your expected squared divided by your expected. Going back here, our observed is 24. We're going to subtract 24.5 squared. So we'll say 24 minus 24.5, and then square the answer and divide by 24.5 and say plus, and then move on to the next one. 32 minus 30.8, 32 minus 30.8 squared divide by 30.8. And you do that for the whole table until you have covered all the values. And when you calculate, you find that it is 0.709. Finding the critical value, we use alpha and the degrees of freedom. And our degrees of freedom, if this is our alpha of 0.05, and the degrees of freedom, remember, is your number of rows minus 1 times the number of columns minus 1. Going back to our table, number of rows, 1, 2, 3, 4 rows, number of columns, 1, 2, 3. Do not count the totals, they do not form part of the table. Only the values of your categories. 1, 2, 3, 4, our row totals. Our number, there are 4 rows and there are 3 columns. So 4 minus 1 times 3 minus 1, which is 6. So our degrees of freedom of 6. And when we go to the critical value table, we will find that that is 12.596. Now, based on the test statistic that we have and the critical value, we created our region of rejection. We can look at where does that 0.7094 fall. It falls in the do not reject area. So we can make a decision and say, hence, our test statistic is less than our critical value. We do not reject the null hypothesis, and we can conclude that there is sufficient evidence that the meal plan and class standing are independent. Are dependent on each other. Let's look at an example by way of looking at the exercise. So since on this table they didn't calculate the total, the best thing to do is to quickly calculate the totals of this table. And we have 18 plus 12 plus 20 plus 28 equals, and this will be 78. And then the next one, 38 plus 26 plus 34 plus 24 equals 122. If I add both of them, 122 plus 78, I get 200, and that is our grand total. Do the same. 18 plus 38 equals 56. 12 plus 26 equals 38. 20 plus 34 equals 54. And the last one, 28 plus 24 equals 52. Just to double check, 56 plus 38 plus 54 plus 52 equals 200. So, and that are our totals. So now we can come and answer the question. We're looking for the incorrect one, but I will just continue with all of them so that I can show you how to answer the questions. The expected value for youth and girls. So we're looking for youth and girls is for 12. So remember, the expected value for 12 will be the row total times the column total divide by n. So what is our row total? Row total for girls is 78. Multiply by column totals for youth is 38. Divide by 200. So here we have 78 times 38 equals, divide by 200 equals 14.82. So that is correct. It says, number 2, the null hypothesis states that gender and magazine preference are independent. And that is correct, because in your null hypothesis, you always state that the two categorical values or variables are independent. The alternative will state that they are dependent. If I look there, that is correct, that is correct, that is correct. The degrees of freedom, remember it is R minus 1 times column minus 1. Number of rows, there are 2, so that will be 2 minus 1 times number of columns. There are 1, 2, 3, 4 columns, so it will be 4 minus 1. 4 is equals, 4 minus 1 will be 3, multiplied by 1, it's 3, so that is correct. Number 5, it says the chi-square distribution is symmetrical. And if I look at this, it is not symmetrical. And this is one of those where we say there's a non-distribution. It's always going to be a left skewed data because the tail is always to the right. It will be right skewed. So this is the incorrect answer. And that's how you will answer the questions. The other exercise will also do this. So they already calculated the totals here, so it makes it easy. They say the expected frequencies, we're looking for the incorrect one. The expected frequency of social media and politician is that. So remember, expected frequency, the row total, multiply by column total, divide by n. Our row total for social media is 3015 times our column total for politician is 1050. Divide by 4000. So this will be 3015 multiplied by 1050 equals divide by 4000 equals 791.44, which this is correct. Expected value for traditional media and sports star, that's traditional media, it's 985. So we go 985 times sports star is 6665 divide by 4000. And that will be 985 times 665 equals divided by 4000 equals 163.76, which makes that correct. The observed frequency, so the observed frequency are those values on the table. It says the observed frequency for traditional media and politician is 350. That is correct. The null hypothesis is that the media platform, which are media platforms, and personality are dependent. We always know that in the null hypothesis, it should say they are independent. So this is the incorrect one. Our degrees of freedom, number of rows minus 1 times number of columns minus 1. Number of rows, we have 2 minus 1. Number of columns, we have 3 minus 1. Therefore, it will be 1 multiplied by 2, which is equals to 2. And that would have been correct. And that is how we do the chi-square test. And that concludes today's session. Just to recap on what we did today, we looked at hypothesis testing and also the chi-square. So when we're doing the hypothesis testing, we looked at how to do the hypothesis testing for the mean when the population standard deviation is known, and that we can use our critical value or p-value to make the decision. We looked at how to perform the hypothesis testing when the population standard deviation is unknown, and we applied also the theory of one-tailed test and the two-tailed test examples. Then we last did the hypothesis testing for the proportions. Remember, with hypothesis testing, all 6 steps of the hypothesis testing can be options in the question that you need to know to be able to answer all the questions in the exam, which are: first step, stated the null hypothesis and the alternative. They will always give it to you sometimes in the question, but we just need to know how to state that. Number 2 will be to state what you are given. Number 3, what kind of a test are you doing? A t-test or a z-test? Number 3, What is the critical value that you're going to be using? You need to find that critical value, because with that critical value, you need to be able to know where your region of rejections are. Step number 5, you calculate your test statistic, and step number 6, you make a decision. Lastly, we looked at the chi-square test and chi-square test for independence. We said, when you state your null hypothesis and your alternative, you always state that in your null hypothesis, 2 categorical variables are independent. In your alternative, it will say they are dependent. You need to calculate your expected frequencies. Expected frequencies are the row total multiplied by column totals divided by the grand total, which is your sample size. To find the critical value, you use the degrees of freedom, which is your row total, your number of rows minus 1 times the number of columns minus 1. And that's all what we did today. And that concludes today's session. Thank you for coming. Bye. Oh, are you there? Oh, sorry. I thought I'm alone. Any question?
None, but thank you very much, Ms. Bowie.
Thank you.